Hi, my name is Fujawan.
My name is AISYAH.
Hi, my name is ZAHRAN.
Assalamualaikum and good day. My name is MIRZA.
The production of benzene via hydromethylation is being studied. Hydrodemethylation is one of the processes that can be produced benzene, where it removes a metal group such as metal cyclohexane from toluene. This process typically performed at an elevated temperature around 500 degrees Celsius and higher to produce a high purity benzene. There are many methods in HDM process such as catalyst, uncatalyst, and alternative reaction. Therefore, for this study, a common method is chosen, which is known as Hydrodemethylation method. In this process, toluene and hydrogen is combined into a mixture where it will be heated up until it reaches an optimum temperature before it is mixed into a reactor with catalyst to undergo conversion reaction. After that, a separation is done in gas and liquid phase to gain high purity of benzene with carryover toluene or hydrogen to be used for conversion reaction. In the process, the most common catalysts that we use are oxides of molybdenum or chromium and supportive platinum such as SiO2 or Al2O3. In choosing a suitable reactor for this production, some consideration is taken such as its reaction mechanism, rate expressions, and the required production capacity. Hence, the fixed bed reactor is chosen with the presence of catalysts to undergo reactions. Its advantages are uniform temperature for pre- and post-conversion reaction, long-term energy storage, with monitoring and optimization of temperature conditions within the reactor. At the same time, in reactor materials, stainless steel 304 is chosen due to its temperature and corrosion resistance, with cost-effective due to widely availability.
In HDM process, in total, there are actually 3 kind of separator, which is high pressure separator, low pressure separator, and also distillation column. So for high pressure separator, the operating condition is actually in 40 degrees Celsius and also 30 bar. The separation involved is actually the reacted product and also excess hydrogen. The low pressure separator will be operated at 7 to 14 bar. The separation involved is usually the methane gas and also the heavier product as well. Lastly, for the distillation column, the distillation column was operated at around 38 degrees Celsius and also 32.8 bar. The separation involved is actually our targeted benzene product and also the heavier tar product. The benzene product, which is lighter, will be collected at the top of the distillation column, where it will be stored in a tank. While the heavier tar product, which is usually consists of much heavier polyaromatic compound such as toluene, naphthalene, biphenyl, and some more. For the solid byproducts of HDM process, the most common one that we can find is actually in tar itself, where the majority is actually composed of naphthalene. So naphthalene is actually a white crystalline solid, which is also a very volatile, which will produce a pungent smell. Naphthalene usually involved in multiple kind of field, which such as plastic, chemical, agriculture, textile, and also building construction. The many applications of naphthalene involved in use in the mothballs, production in phthalic anhydride, manufacture of PVC, and also used in artificial resins such as glyptal, and also used in pharmaceutical. Naphthalene also used actually as intermediate, such as naphthalene will undergo sulfonation and neutralization reactions to produce 2-naphthol, which is 2-naphthol is actually an intermediate used in order to produce azo dye. And one more is actually naphthalene also will undergo oxidation reaction to produce phthalic anhydride, where phthalic anhydride is actually an important plasticizer used for production of vinyl chloride.
Moving on, one of the liquid byproducts found is cyclohexane, which is a clear colorless liquid with a petroleum-like odor. It is commonly used in textile, plastic, and automotive sectors. Cyclohexane is employed in the creation of perfume, surface coating activities, synthesis of adipic acid, and also as solvent in chemical and industrial processes. Another liquid byproduct being found is methylcyclohexane, which is a clear colorless liquid with a faint odor. It can be converted into toluene through dehydrogenation, cyclohexanol and cyclohexanol through oxidation, and styrene through polymerization. General applications of methylcyclohexanes includes dye solvent manufacturing, additives in gasoline, and cleaning agent. Wastewater is usually found as a waste in every industrial plant. From the aspect of resources and energy recovery, wastewater can be used for biogas production to generate power or heat, thermal energy recovery by capturing heat energy present in the wastewater to preheat the stream, and hydroelectric power by driving the turbine to generate renewable energy. Also, it can be repurposed for uses such as irrigation, manufacturing, or even flushing toilets, and as a nutrient-rich medium to cultivate biological agents for biological processes.
Moving on, there are some gas byproducts formed during this process. The first one is methane. Methane formed as byproduct due to incomplete conversion during catalytic reforming or steam cracking processes at high pressure and temperature. Methane is a clear, odorless, colorless, and tasteless gas. Methane is mainly used for chemical industry and power generation. Methane also can be used to produce other valuable products like hydrogen through steam reforming and formaldehyde through oxidative dehydrogenation. These products are valuable intermediate for other chemical productions. Besides, the raw methane also can be used directly at the plant in the fuel gas system. It can be the energy sources for furnace, boilers, and heaters to provide the high temperatures needed for reactions and thermal operation. Next, carbon dioxide also can be generated as byproduct for this production. CO2 is a well-known greenhouse gas that is colorless and odorless, which is slightly toxic. There are several available CO2 capture and storage methods that can be adopted in this production plant to reduce the carbon emissions. Amine absorption, membrane contactor, and adsorption unit are among the methods that can be used. Captured CO2 later can be kept and stored underground as one of the latest CCS technology suggests. There are also many current studies done for CCS mission mainly to tackle this issue. However, current available alternative seems to be a good start to reduce the emissions.